Another method you can use for identifying the vertex when it's in standard form is the vertex formula. So here is the vertex formula. To find your x value, it's minus b over 2a. Once you get that value, you'll plug it into your function itself, and that will give you your y value. So let's go ahead and do that, but you first need to identify what's a, what's b, what's c of the quadratic. So we can see here the coefficient of the first term we call a, so a is 1. The coefficient of the second term we call that b, so here we can see b is 6. The coefficient of the last term, the constant, is c, so we can see c is 5. And now that we have our values, we're going to start by finding our x value. So that's minus b over 2a. That's going to give us negative 6 divided by positive 2, which is negative 3. So now we have a negative 3 for our x value. To find our y value, you take your result of x and plug it into the equation itself. So I'm going to remove all the x's from the original equation and replace it with negative 3. Do the math. Negative 3 squared is 9. Here this is negative 18 plus 5. Combine those numbers and that gives us an output of negative 4. So my vertex is negative 3, negative 4, the same as we got with the completing the square method. Let's continue on identifying some other characteristics here. How about the axis of symmetry? So we don't even need to see our graph to know where that is. Just look at our x value and put it in equation form. So that would be x equals negative 3. Domain and range. How far does this graph extend to the left and to the right? Because we have arrows on both ends, it's going to go forever to the left and forever to the right. Range, how high, how low? The lowest point this graph falls would be negative 4, and it's going to shoot forever up to positive infinity. We always write it from least to greatest, so that would be starting at negative 4 with a bracket. Go forever to infinity and always close infinity with a parenthesis.